Hello. In this video, we will be talking about the t-test for a single population mean when sigma is unknown using the p-value. So this test is a statistical test of the mean and is used when the population is normally or approximately normally distributed and the population standard deviation sigma is unknown. So if sigma is unknown, we will be using S instead. S is the sample standard deviation, and S can be found because we will be working with samples. So keep in mind, whenever you are testing the population mean mu, when sigma is unknown, you'll be using this very specific test, which is called the t-test. Now, we know the steps. We will practice on the examples. But first, if we were to do this by hand, the formula for the test value or test statistics follows the same general format that a standard score follows. And if you do recall, the standard score followed this general formula. Let's just write it down. This is the general formula for the standard score. We use the same one for the z-test, but we called it a z because we were using the standard normal distribution. In a t-test, we will be using the t-distribution. When we use the t-distribution, we know that it is crucial that we know which curve of the family of curves we pick, and that's why we always should state the degrees of freedom. The degrees of freedom for this t-distribution is n-1, so follows the same rule that we learned when we talked about confidence intervals. And the t standard score takes the value of the mean, and the value of the mean will be a mean of a sample minus the actual mean or the true population mean, and that will be mu. Because we do not know sigma, we'll be using S instead, divided by square root of n. This is the standard error, and we know this from the central limit theorem. Let's see how a problem looks like and how we will perform a t-test. Here we go. In 1955, Life magazine reported that a 25-year-old mother of 3 worked on average an 80-hour week. Recently, many groups have been studying whether or not the women's movement has in fact resulted in an increase in the average work week for women, combining employment and at-home work. A study was done to determine if the mean work week has increased. 81 women were survived with the following results. The sample mean was 83 hours, and the sample standard deviation was 10 hours. Does it appear that the mean work week has increased for women? Use a 5% level of significance. So get used with long problems, but don't be scared of this. The best practice, and this is what I always do, try to summarize the results under given and try to make sure you use the proper notation. So this is based on the Life magazine report from 1955, and they stated that on average, this group works 80 hours per week. Now, the study was designed this way. They took 81 women, so that will be the sample size. And these are the results. The sample mean, so that will be an X bar, was 83 hours. And attach the unit measures to the random variable. It will make more sense. And you will see the distinction between 81 and 83. 81 is the sample size. 83 is the time. The sample standard deviation, which means sigma is unknown, which means S is known, and that will be 10 hours. And the significance level is 0.05. The question is, does it appear that the mean work week has increased? In other words, we have to answer this question. Is mu greater than 80? That's the question. So I will answer that question by doing a test, and the test will be for the mean. So let's do a test for the mean. Now, so far we learned about the z-test, which is done for the mean sometimes, and a t-test, which is done for the mean sometimes. So at this point, you should ask yourself which one of the tests we will do. Now, because on this video, we focus on the t-test, you probably know at this point that we will do a t-test, but we will explain why when we get there. First of all, step 1, state the hypothesis. H sub 0, H sub A, I look among the information and I find this. And this is actually the alternative hypothesis. Now, which one will be the claim? Well, we have to read again the problem if we need to, but it seems that they did this study to determine if the mean work has increased. So this is what they claim, actually. So we'll just write down, here is the claim. They were wondering if that increased, so they designed a study for it. And this will be a right tail test. At this point, you know that this is a right tail test, and you write it right here along the H sub A, because H sub A gives the direction of the test. So I'm ready to use the complement on the top for H sub 0. Step 2, state the distribution and what test do we use on the calculator, and of course, alpha. So this is what I will do. The distribution in this case will be the t distribution. Why? Because I am doing a test for the mean, and sigma is unknown. I know S, but I do not know sigma. So it will be a t distribution. When you write down the t distribution, you want to make sure you put the degrees of freedom associated with it. The formula is n minus 1. So in our case, it will be 81 minus 1. So it will be 80 because n is 81, right? The test we will be doing on the calculator will be the t-test. And we'll plug in the correct numbers and we will get the result. And one more thing here, alpha is 0.05. Okay, so this is all that we need to do as step 3. Now, step 3 though, we will find the test statistic. Let's just write down test statistic or test value and the p-value. We are doing the p-value method. So let's do that. Well, we'll actually run the test and get those values from the calculator. Let's take a look at how this works. So here we have the calculator, and all we have to do is click on stats, get to this screen, stats, get to this screen, get to tests, and this time I will be picking the t-test. Hit enter, and this time we have summary statistics. Those are all listed right here under given. So let's just plug in the corresponding values. For mu sub 0, I actually look right here. That's the only place when we have a sub 0. So I'm looking for the equality, right? So this will be the number I need to plug in. X bar is 83, S is 10, and N is a sample size, which is 81. So pay attention to the symbols, pay attention to the numbers you wrote down. And now what type of test? In this case, the test is a right tail test. So I will use this. And here I have my results. T this time is 2.7. And the p-value is 0.0042. Let's write this down right here. I have the result, the statistic, and since I'm doing a t-test, I'm using a t to write that down, 2.7. And the p-value, and I'll call it p-value, is actually 0.0042. Okay, now if I want to sketch the graph, this is how I will sketch the graph. This is a t distribution, t. Degrees of freedom, right away, I put that down here is 80. So this is the curve from the family of curves. It's a right tail test. So here I have the area that's shaded. Right here on the bottom, I'll have the 2.7. And right here, I have the area of 0.0042. Okay. And all I need to do now is make a decision. So at step 4, I'll make a decision. And I don't want to scroll down because I want to have all of this on the same screen. So I will simply use this part to write down the decision. The decision is based on the p-value method. So I will simply compare the p-value with alpha. I have the p-value listed right here, and I know alpha is listed right there. And actually it is listed right here for that reason. If you're not organized, if you don't have it on a side, it's good to have it at step 2. So I start with p-value. Always start with a p-value, okay? And then I put the alpha. I make sure I have the same number of decimals. And I can see easily that this is actually less than, the p-value is less than or equal to alpha. And I know that when that happens, I'll simply reject. H sub 0. Okay? Now, that's the decision. What's most important is the interpretation. But the interpretation should be stated in a very specific way. I will start this time with the level of significance at 0.05 level of significance. There is or is not enough evidence or sufficient evidence to support or reject the claim that the mean, and now I simply have to read it from here, the mean work week has increased for women. So you have to make sure to write it down in a sentence like this, put it in context. So let's see, what do we put in here? First of all, look at this, reject H sub 0, which means I do not support H sub 0. Reject means no, not going with that. So what is left? Well, H sub A. How do I start when I end up with rejecting H sub 0? We always start with there is. Let's see, at 0.05 level of significance, there is enough evidence to support or reject. Remember, this was the claim. I erased that, but that was the claim. So am I supporting now the claim or rejecting it? Now, if you look at this, it seems that I'm left with this to support. So the word right here will be support. And read it again to make sure it makes sense. And this is how we conclude a t-test. Let's take a look at another example. Coffee consumption. The U.S. Department of Agriculture claims that the mean consumption of coffee by a person in the United States is 24.2 gallons per year. A random sample of 120 people in the United States shows that the mean coffee consumption is 23.5 gallons per year with a standard deviation of 3.2 gallons. At alpha 0.05, can you reject the claim? I will write down the given information using the proper symbol. Here is the claim, and here is the parameter we will be testing, the mean. And they say that the mean is 24.2 gallons per year. So that will be mu equals 24.2 gallons. And now they design the study. They take a sample of 120 people. That will be N. And it shows that the mean consumption for these people is 23.5 gallons per year. So that will be an X bar information that comes from the sample. And also the standard deviation, and it comes from the sample, right, will be S. So that's an S, is not a 5, just letter S, and it is measured in the same units measure. Alpha is 0.05. So the question is, can you reject the claim? And the claim is this one. So let's do a test. And you want to make sure that you know what type of test you are doing. You are testing the mean, test for mu. So this is what we will do. I'll start with the step-by-step process. First step, and make sure you always write the steps in order. That's where you should start. H sub 0, H sub A. This is given. This is the claim. This is an equality. So it will be mu sub 0. You know, the equality is very important for the null hypothesis. And this is the claim this time. Okay, so I'll write down the claim right there. And now the alternative hypothesis will be the complement. Well, what is the complement of this? Mu not equal to 24.2 gallons. And right here, because this gives the direction of the test, I will say this is a two-tailed test. At this point, some students can visualize the graph, right? You should see the two-tailed shaded in under the distribution. But which distribution? Well, because S is given, not sigma, we'll be using the T distribution. So let's state that. And whenever you use the T distribution, make sure you write down degrees of freedom, N minus 1. So it will be 119. And also, you write down the test. This is the calculator command or calculator function that we will be getting the results from. Okay? And don't forget, alpha should be stated here. However, if you write down the information right here, the way I taught you, you don't really need to put it anywhere else, but this is the second step. So third step, we will find the test statistic and the p-value. So test statistic, because we are using the t-distribution, that will be named t, and the p-value will be the p-value, and all of this will be results of the t-test. So let's take the calculator and do a t-test. Here is the calculator. Click on Stats, go to the test, scroll down to t-test and hit enter. And right here, we simply need to input data. We have statistics. Mu sub 0 is whatever information it's mu equal to, and this is 24.2. Scrolling down, x bar is right here, 23.5. Scrolling down, S, 3.2, N, 120, and we are doing a two-tailed test. So this will be not equal to. Scrolling down and down, we will hit calculate. So this is what we are interested in, test statistic or test value, and the p-value. So we have negative 2.39, well, actually it is 2.40. If we round to 2 decimal places, that's what we will do. And the p-value is 0.0181. This is an area, we round it to 4 decimal places. So let's see now, how do we conclude the test? We will reach a conclusion in step 4. So here is decision time, p-value 0.0181, alpha 0.05. Looking at these two, we see that this is less than 0, right? We can use less than or equal to. So again, we reject the null hypothesis. And just because we reject the null hypothesis so many times in this example, it doesn't mean that all the time you will be rejecting the null hypothesis. It just happens that for these examples, we reach this conclusion. And what does this mean? Let's just interpret. And again, this is very important. Interpretation is very important. So I will start with the level of significance at 5% level of significance. There, and I'll put a blank in here and think about it, enough evidence to support or reject the claim that, and I simply put the claim in words, the mean consumption of coffee by a person in the United States is 24.2 gallons per year. So this is the claim. We'll have to actually write that down here. I will use symbols, but put it in context, okay? So let's see. How do we fill this in? Keep in mind, we rejected. When we reject, we always put is in here. If we fail to reject, or if we do not reject, we will put is not, okay? So we rejected H sub 0, meaning we do not support H sub 0. We reject. Look at this. That happened to be the claim, which means this is gone too. And we are left with this one to support. So are we supporting the claim or are we rejecting the claim? There is enough evidence to, and hopefully it makes sense. And this time, because we rejected H sub 0 and H sub 0 was the claim, we're actually rejecting the claim. And here is another example. This will be the last on this video. This example is based on data, not on statistics. That's the reason I want to go over an example like this. In tests of a computer component, it is found that the mean time between failures is 520 hours. A modification is made, which is supposed to increase the time between failures. Test on a random sample of 10 modified components, resulting in the following time. We have data. At 0.05 significance level is the claim that for the modified components, the mean between failures is greater than 520 hours. So let's write down the given information. It says that the mean time between failures is 520 hours to begin with, and they want to increase that. So they make a modification to increase the time between failures. And then they have the results from 10 modified components. So N will be 10, and data will be given. That's it, raw data. But when you have data, you have so much information, right? Alpha is 0.05, and you want to see or test the claim that the mean is actually greater than 520 hours. So the question, we are actually doing an hypothesis test for the mean. Let's do that. Step 1, what are the null hypotheses and the alternative hypothesis? What is the claim and what type of test I'm doing? All of it is right here. So this one, which is the claim, will be strict inequality, which means will be the alternative hypothesis, and I'll write next to it, this is the claim. And also I can write the direction of the test right away because I know H sub A gives the direction of the test. This is a right-tailed test. Now this one then will be the opposite or the complement. I can write it down mu less than or equal to 520 hours. I'm done with the first step. Step 2, what is the distribution we are using? Well, I look among this information and I don't really find sigma and I don't really find S. I know I'm doing a test for the mean, but I'm wondering, should I use a z-test or a t-test? Well, when raw data is given, if I put it in one variable statistics, I will be able to find a lot of measures, including S. So when raw data is given, S, it's available to us. Because of that, I know I should be using the t distribution. I write down the degrees of freedom, and I hope you know by now that n minus 1, in this case 10 minus 1, is the formula for the degrees of freedom. In this case, it will be 9. I will perform a t-test, find the result, and I know that alpha is 0.05. So at step 3, I'll write down the results, the test statistics, or the test value, which in this case will be a t-value, and the p-value. This will be the results after I run the test on my calculator. Can I do this without running the test? Yes, I have a formula for t, and then I can find the area under the curve using a t-distribution. So we can do that without doing the command, but for now, let's just do it this way, and this is what you need to do. Go to stats. The first thing you will need is to edit. All of these values need to be put in a list. So hit enter since you are in edit. I already entered the values in one of my lists, list 1. So make sure you enter these values in list 1. Then go back to stats. And then go to test. I will pick the t-test, and I already know why. Hit enter. This time I do not have statistics, I have raw data. So what I will do, I will use arrows to get to my data. Make sure this is highlighted. Hit enter. And I'll simply plug in the information. What is the mean equal to? Well, equal to 520. Do I have my data in list 1? Yes, I do. Frequency stays 1. What type of test I'm doing? I wrote down, this is a right-tail test. And let's have the calculator calculate the value. And here we go. We have t as 2.61, and the p-value, it's 0.0140. Now, if I want to see the graph, you simply sketch the graph. This will be a t distribution with degrees of freedom 9. This should be symmetric. Okay, imagine this is symmetric. This is a right tail test. The area in the right tail is the p-value, 0.0140. And the value, which is the test value as a test statistic, is 2.61 right here. You think back of how to find this without running the t-test. Well, if you have the t-value right here, you will do the t-CDF to find the corresponding area. Or if the corresponding area is given, you will do the inverse t to find the t statistic. We will actually do something like this in the future videos because we need to find values this way. Just wanted to remind you that sometimes when we don't use the t-test, we can find these values employing some other calculator command. But now let's go back to our problem and conclude the test. Here we have step 4. I take the p-value and compare it to alpha, 0.0140 and 0.05. Now add 2 more zeros. We see that this one is less than or equal to alpha, so I will reject H sub 0. And now the final step, which is interpretation, should be stated this way. At alpha equals 0.05 or 5% level of significance, there blank enough evidence to blank the claim that, and you will simply copy this down, the mean time between failures is greater than 520 hours. I will write it down like this. And I will invite you to stop the video and try to plug in these words. After that, come back and check if we have the same results. So I hope this makes sense. With this, I conclude the video.